So hello everyone. So this is we are preparing for function 3 and मैं कोशिश करूँगा कि आंसर सिंपल वे में दूँ. ठीक है. So let's start. Hogging क्या होता है? Basically hogging is a kind of a global stress in which the the weight is distributed at the end of the vessel, and the buoyancy is maximum at the center, and the vessel is bent from the center, and it is called as a hogging. Wherein sagging, the vessel tends to bend inward from the center because most of the weight is centered at the midship of the vessel, and the buoyancy is more at the edges of the vessel. So in this it is called as sagging. So the vessel will bend at the center inwardly. Okay, so how we have to say, like, when a ship is loaded in such a manner, ship exists uh, that axis of weights at the end, whereas axis of ones in the middle, then she will tends to bend upward amidship. Okay, bend upward and downward in sagging. Okay, rest everything is same. Now what is racking is basically and distortion, transverse movement of the vessel, distortion of the vessel because of the rolling. When a vessel is rolling seaway, the transverse section try to distort quantity due to racking stresses. Okay, now what is torsion in that when a vessel is having a rolling and pitching at the same time, that the vessel bow will take the wave on either side of the bow, like the vessel twist longitudinally is called the torsion. If a vessel is subject to a pitching and rolling at the same time, that is taking the wave either on the bow, the vessel tends to twist longitudinally. These are known as torsion stress. ठीक है. Now water pressure is kind of force which acts perpendicular to the hull of the vessel. This produces a collapsing stresses which must be resisted. Okay, surface of the submerged hull increases with the depth. Okay, and it increases. Okay, now what is dry docking? Dry docking is nothing but when a vessel, when the water is removed, when the vessel is has the weight on the blocks. In dry docking, the hull of the ship try to sag downwards. This is called a dry docking force. When a vessel is dry docked, the thrust from the water is removed. Okay, the hull on either side of keel stick tends to sag downwards, and the beams are in tension. Keel block, bilge block, and side shores are needed to support the ship. And now the arrangement of keel and bilge blocks are different for each. Okay. Local stresses. What is painting? So this is all about global stresses. Okay, this come under. And what is local stresses? Local stresses it comes under painting, which painting is kind of in and out motion of the forward part of the vessel, and because of the waves of the coming hitting the forward part of the vessel, and basically we have a collision bulkhead for that in the forward part, which is and it is more around 15% of the length from the forward perpendicular to the aft. So basically 15% is the most affected area of painting, and we have a painting stringer over there which is around fitted in such a way which is 2 meter apart from each other in the collision bulkhead forward region. So what is painting is an in and out motion of the shell plating caused by the fluctuation in the water pressure. So this is what I have missed, caused by the fluctuation in the water pressure because of the water waves. In order to prevent this, classification has given expression in the form of beam brackets, stringers, etc. Okay, beam brackets, this we have to use beam brackets and stringer. I have missed this. So beam bracket and stringers. The structure on the forward end is strengthened to resist bending at 0.5 after the perpendicular. Okay, 2 meter apart painting stringers. Okay, so intercostal sizes are fitted with the paint. Okay, after between the collision bulkhead and after the. Okay, now what is pounding? Pounding is basically a slamming of the vessel when the vessel gets in upward direction and hits the waterways with a slamming effect. It's called re-enters with a slamming effect. It's called a pounding. So It is mostly happen in the heavy weather only, and for this we have a intercoastal side girder with, and they are separated by 2 meter from each 2.2 meter apart from each other, and this is all over. And in that we have 0.15%. Here it is 25 to 30% region is known as ponding, which area is impacted by the ponding. Extra strengthening is required to reduce the damage, like the forward perpendicular is strengthened for between 25 to 30 years of the depending on the ship's length, block coefficients, and depending on ship's block coefficient. Okay, now plate floors are fitted on each frame sections or alternate frame section, longitudinal framing with intercoastal side girders, longitudinal with intercoastal side girder not more than. Okay, so we have alternate frames, plates floors are fitted on each frame stations or alternate frame stations. Okay, with intercoastal side girders not more than 2.2 meter apart. The four stage of shell plating. Okay, so depending on ship's location, plate floors are fitted on each frame sections or alternate frame stations. Okay, this is all about. Yeah. So now what are the frames? So basically the shell plating is supported by the vertical frames, transverse frames, longitudinal frames, and all. So these are vertical frames. The side shell plating of the vessel is supported by the vertical frames. They are normally 760 apart from each other, and it is broken at the twin decks, and inside upper the frames which are above the twin decks are less thin, and which is downward in the hold they are around 300 thick, and this is the frame which we have. Now we can have two types of frame, is a longitudinal or either a transverse frame. In longitudinal frame what happens, the strength of the frame is not broken, it is continuously in a longitudinal direction, and side longitudinal is supported by the transverse web, and they are supported they are at the side shell of the transverse side of the vessel. They are apart from each other by 3.8 meter, and this longitudinal framing are done mostly with the vessel which are more than 70 meters, and transverse framing is a kind of stiffeners which are along the breadth of the vessel, and the vessel length is normally less than 70 meters. So this is a lot of transverse framing, and in combination we use both. Okay, so this is all about. Okay, so we have or less, so 3.8 transverse webs. So I don't know what stiff transverse webs are fitted to. So the whole frames are of larger section. Okay, so thin windward I don't have to used. So the side shell supported by frame which run vertically from the tank margin to the upper deck. Okay, side shell frames. This is usually of angle sections. I missed this word, angle section, which are spaced about 760 apart in the form of bulk section. Bulk angle sections which are spaced about 760 apart from each part in the form of bulb angle. The length of frame is usually broken, and the length along the smaller section to be used in the twin decks. The whole frames are of larger sections, typically 300 bulb angle or plate. They are connected at the tank margins by two flange tying side brackets. Okay, okay. Now this is about. Now what is strake? Now the side the shell plating of the vessel, like all the plates are welded together to form a side plating of the vessel. So this welded part is named according to their positions, which are called as strakes. Strakes are not a single plate, but they are welded in a plate. Shell plating is not made up of single plate, it is made up of smaller section of plates welded. These plates are joined together and numbered in certain pattern, A strake, B strake, and so on. Which are okay. So garbo strake, which is adjacent to the keel plate, is named as alphabet, and starting from A in the vertical direction, each plate is given number horizontal direction. Now keel plates are given from aft to forward, starting from 1. Now keel plate is also made of smaller section of steel plates. The strakes of plate that form the keel of the vessel are called keel strakes. Okay, side shell. So this is easy calculating main deck, and coming to beam knee. Okay, so we'll be doing some shortcut as well, because now there it takes. Now, what is beam? Beam are basically a transverse beams which support the side shell, and they are used in conjunction with the longitudinal girders. The deck may be supported either. Okay, so this is what totally bullshit. I don't know. The deck may be supported either by transverse beams in conjunction. So we have to use the, if they are asking me beam, then I have to use the word deck. The deck may be supported either by transverse beam or in conjunction with the longitudinal girders. The beam knee, the transverse beam knee, the transverse beams are carried across the ship and bracket to the side frame by means of beam knees. The transverse beams are carried across the transverse beams across the breadth of the ship, okay, to the side frames by means of bracket beam knees. The transverse beams are carried across the ship and they are connected to the side frame by a beam knee. Okay. So what is transverse beam? A beam arrangement. Okay, so transverse beam are used mostly in vessels which are less than in 120 meter, they have said, and transverse beams, okay, and more than longitudinal beams they are using. Racking stresses and hogging and ships usually found in tankers fitted long. Okay, so you have to word the use. Okay, so tanker definitely. Okay, no issue. So this is mostly used in tankers fitted longitudinally. Okay. Beam arrangement often adapted for ships expensive seaward runs along the breadth of the ship. Okay. Now, what is bulkhead? Bulkhead can be of a watertight bulkhead, non-watertight bulkhead, or a collision bulkhead, or a transverse bulkhead. Sorry, so non-tank bulkhead. Okay. There are three basic type of bulkhead found on ship: tank bulkhead, and additional bulkhead is a longitudinal if survey is not set. It was a collision bulkhead. Okay, so minimum distance is 0.05 or 10 meter or 0.0 0.08 plus 3 meter 0.08 L plus 3 meter or 0.0 10 मीटर या तो क्या था यार 10 मीटर 0.05 L or 10 meter or 0.05 L plus 3 meter or 0.08 L. Okay, this is the maximum distance. Okay, now this is can be a corrugated bulkhead or in corrugated bulkhead basically they have said like there can be of three types: the corrugated bulkhead with stools at the bottom or without the stools at the bottom, and with upper and lower with stools. So the vessel with normal vessel don't have any stools, and this is mostly used on small vessels, product tankers and all. And the vessel which have a lower stool used on basically vessel more than 40,000 deadweight, and the vessel with have both upper and lower stool are mostly Aframax. So sorry, the without any stool is on product tanker. Okay, this arrangement is on small tanker. So this is all about. And why corrugated bulkhead is because of the lower mass and no corrosion problem and expansion property, and easy for cleaning, easier maintenance. 40,000 deadweight has found application on ships exceeding 40, mostly on with lower stool. Okay, and the person an Aframax size will. Now there has been horizontally of this corrugated bulkhead is there, which can be either a transverse or a longitudinal, and this is mostly used on small tankers and product tankers, tank easy for tank cleaning and all, and chemical tanker where is of primary importance. So this is advantage is basically as clear that it has an expansion property because of thermal in load, expansion by thermal load compared to flat stiffened bulkhead, and easy for maintenance, and lower mass, easy loading, unloading, easy maintenance. So this is all about. Now coming to this rudder. Rudder is basically helps in steering of the vessel, which depends on the ratio of the forward and aft from the rudder stroke. It is divided in three parts: unbalanced rudder, balanced rudder, semi-balanced. The turning action of the rudder depends on the area of the rudder, which is typically in order 1/2 to 1/6 of the product of the ship's length and the depth. The turning action of the turning action of the rudder depends on the area of the rudder, which is typically in order of the product of the ship's length and depth of product of the ship's length and depth product of ship's length and depth. The turning action of the rudder totally depends upon the ship's length and the depth, which is typically around 1/60 to 1 of the product of the turning. Okay, now unbalanced rudder is mostly a 40 to 60% ratio, where it is 40% to is which is ahead of the behind the rudder stroke. So the turning action is not as good, because the whatever water flow coming from it hits the hull. So I don't know how to repair. This time rudder has its entire blade area behind the rudder stroke. Unbalanced. The leading, which is indirectly facing the propeller, is connected to the stroke to provide all turning torque. In unbalanced rudder, the steering gear has to provide the turning torque, and the blade on the hand is exposed to larger bending moment. Thus, unbalanced is not widely used in modern ships. Okay, balanced rudder is the 20-30 balance forward of the rudder stroke. Forward of the rudder stroke we have to use. Okay. Water pressure striking on the forward of the turning axis. Water pressure striking, this word I have to remember. Water pressure striking on the forward part of the turning axis compensate the water force acting on the aft part. Okay. Now semi-balanced, the 20% of its blades are forward, the stroke is old system is special forward is this. Okay, no issue. Now diameter is basically the area which is created by the tip of the propeller. Tip as propeller rotate defined as the maximum pitch. The linear distance traveled by the propeller in one axis, one rotation, considering it has in a solid medium, not allowing for slip. This is all about the mean that if I have a propeller of one pitch, it will advance 40 inches. Okay, for every complete spin. Okay, 40 okay. A liquid might manage the propeller will always slide with less displacement. So this is in one. So right-handed propeller which we've seen from aft, which make a movement clockwise when seen from the aft, is a right-handed propeller, and the left hand which makes opposite. And the difference between the for single screw the propeller will be right-handed propeller, and for twin screw the vessel which has two propeller starboard side is a right hand. This is sleeve difference between the theoretical distance the propeller should travel in one revolution. The distance between the theoretical distance the propeller should travel in one revolution and the actual distance the vessel travel. Slip is the distance. Pitch angle is nothing but the difference between the face plate of the propeller and the axis of rotation, the plane of rotation. The face plate of the vessel, this is the side of the plate facing the direction of the motion, the plate rotation. Now, types of propeller: fixed pitch propeller or controllable pitch propeller. Now this is it. So what is the advantage? And azimuth thrusters. So azimuth thrusters are also called aziports, are propeller mounted in the ports. What I have to say is azimuth thrusters are also called aziports.
Azimuth thruster, also azipods. Was it azimuth thruster? Azimuth thruster is basically the propeller is mounted on a unit. Propeller is mounted on a unit which moves horizontally, helps in steering the vessel, which is commonly used on small vessels and not possible to be used on large vessels. Therefore, container vessel and other vessel require tug for it for the steering moment. So it's difficult to reverse and it's very difficult to reverse. Azimuth thrust, also called azipods, mounted on a pod. Mounted in the pod that provides thruster and steering by rotating the unit horizontally. That provide thrust and steering by rotating the unit horizontally. Turning vessel provide forward thrust and rudder that produces drag by turning. This setup works great on small ship on area like container needs structure. Large ships with small rudders just don't have the agility to turn quickly, and their adjustment difficult. Because keel has the maximum weight of the ship and it's called regular essential rigidity and strength. Support to the body structure and keel extending along the hull supporting what to stern. Okay, what is function of the bilge keel? Bilge's keel is nothing but an extended portion longitudinally at the outward portion, longitudinally at the bilge side, which don't have any portion inside the vessel affecting the machinery, and it used to dampen the rolling motions and provide us longitudinal strength, and it support the bilge when the grounding and what do you believe, and that's it. So striker blade is fitted to the bottom while taking the damage entered because of repeated contact with the end weight of the sounding tube. Whenever coffin plate is nothing but when two side plates are connected to the keel at the stern, it seems like a coffin. This is one of the plates joining two side plates over the keel of a vessel at the stern, which in plain views creates a shape similar. Okay, now Steeler plate is basically nothing when two plates combine together to form a single plate is called a Steeler plate. And the iron ship building, the end plate of a stake of outside or inner bottom shell, which is dropped out as the girth of the narrow towards the end. It place where two stakes merge into one. When two plates stuck at the girth of the bottom plating, which is dropped out as the at the girth of the vessel, normally which narrower towards the end. So used to connect the stem to the bilge flat plate keel. Stem to the flat plate keel. Stringer plate is basically stringer plate. Stringer plate is an outward deck structure. Outward structure from the deck. It is one of the plates forming the outer strake of a ship's deck. It is one of the plates forming the outer strake of the ship's deck, and usually heavier than those used for the rest of the deck, and being usually heavier than those used for the rest of the deck. Outer strake word है stringer plate. Outer strake I have to margin line 76 ठीक है. Shear, it is the curvature of the deck in longitudinal direction. Curvature of decks in longitudinal direction as the height of deck at the side at any point about the deck and amidships. Now, what is camber curvature of in transverse direction? One of the longitudinal, these are wheels, side steel plates, sometimes beams connected to the bottom of the ship. Sharing one to now the center of gravity is that point through which the force may consider to act vertically downward with the force equal to the weight of the ship. List the transverse inclination caused by unequal distribution on either side of the center line of the, in other words, list is caused by the switch of ship is not in the center line. Internal cause shift the list will become upright only if the CUG is brought to the center line. Okay. And transverse meter center. When a vessel is held by an external force, the force of buoyancy acting vertically upward through a new position. Now, what is meta center? Transverse meta center. Basically, transverse meta center. In that, what happened when a vessel is upright and when the vessel is not upright because the center of buoyancy has changed because of external forces, then the line passing from vertically from this new center of buoyancy cuts the center line of the vessel when it was upright. Is the point which intersection takes place is called the transverse meta center. That point is called transverse meta center, denoted by M, and the distance between Km and the termed initial Km. When a vessel is hailed, the force of buoyancy acting vertically over the new position of COB at a point called transverse meta. This point is indicated by its height above the keel in meters. Km increases, the angle of heel increases. Km increases until it is maximally at some angle of heel. It decreases as the angle of heel increases. However, as further increase, it decreases further. Decreasing. Decreases, however, over small angle until it reaches a maximum value at some large angle of heel. Large angle of heel. It decreases as angle of heel increases. Small angle of heel at 15 the km is generally small, hence km is considered for small angle of heel. Now, what is meta center? Now, meta center is something which is meta center GM. So, the distance between the GM is only positive when G is lower and negative when the G is above the M. And the meta center, and this is happen is the vertical distance between the center of gravity and the meta center in term positive and G is below the. So, what is righting lever and righting moment? Righting lever is basically a horizontal distance between the center of gravity and the line from the center of new point of center of buoyancy. Basically, when vessel heel, the center of buoyancy of the vessel changes. So that horizontal distance between the new center of buoyancy and the center of gravity is known as GZ, and it tries to upright the vessel. And GZ equals GM sin theta, and GZ equals to GM sin theta, and GZ equals to GM plus half AM tan square theta. GM plus half AM tan square theta. Tan square theta sin theta. For small angle is up to 15 degree. For more than as in the force of centric transverse metacentric and metacentric height is GM. Okay. So metacentric height is for GM. Metacentric height. Okay. Now, what is righting moment? Righting moment is nothing but the W into GZ, the moment required by the vessel to upright the vessel, is the righting moment. When vessel is heeled, the center of buoyancy is being changed. The moment required, so the buoyancy acting upward and center of gravity acting downward is been separated by a horizontal distance, and the couple is formed, and the moment required to upright this vessel is called a righting moment. When the vessel is heeled, so acting equal and opposite becomes separate, and the moment of the tendency of it. So W into G is for GM sin theta. GM sin theta. Metacentric radius, that is BM. Metacentric radius is nothing but the distance between center of buoyancy and the metacenter M. Center of buoyancy is nothing but the geometric center of the water plane area of the ship, it point through which ship require when her trim is changed due to the shift in the weight in the foreign of direction, loading or discharging cargo. So it is also called a tipping center. When her trim is changed. Hydrostrain is nothing but the draft and the displacement of mass of the ship intensively the mass of the ship and when from the mass of the display equal to the mass of the ship. That way the total mass of the cargo fuel and that you can carry on summer load line. Reserve buoyancy, the volume of the enclosed space over the water line. It may express the volume in metric as a percent of the total volume of the ship. Now, what is water plane coefficient? Coefficient of fineness of water plane area is the ratio of the water plane to the water plane to the area. To the area of the water plane to area water plane coefficient of plane. Area of a rectangle having the same length and maximum breadth divided by length is the ratio by the same length is the ratio of the area of the water plane to the area of the rectangle having the same length and maximum breadth having the same length and maximum breadth. Block coefficient is nothing but the underwater volume divided by the total maximum length, breadth and depth of the vessel. Coefficient of fineness show of the underwater rectangle works in the same extent dimension. Freshwater allowance. Freshwater allowance is nothing but freshwater allowance. Freshwater allowance the increase in draft when going from fresh water to salt water or vice versa. So sea water to fresh water. Usually increases after increases and decreases. W by 40 into TPC. W by 40 into TPC. Dog water allowance is increase in draft when she goes from solid dog water or vice versa. Change in draft. W by 40 TPC. W by 40 TPC. TPC. So what is TPC? TPC is nothing but the change in draft of the vessel by centimeter by loading or discharging the weight. Okay. Any change in draft in tons which should be loaded or to change the vessel. TPC formula area into 1.025 divided by 100 into density. Okay, so density of the center plane to 1.025. So this is okay. MCDC W by GML divided by L into 100. one ठीक है 1.025 मल्टीप्लाई बाय किसी के साथ नहीं है क्या डेंसिटी किसी का चेंज ऑफ वाले. So MCDC is the moment required to change the total trim of the vessel. Longitudinal center of buoyancy is the distance between the forward perpendicular and the from the perpendicular to the center of longitudinal perpendicular and the center of buoyancy. Longitudinal center is the section of the after the water center. It is the point of intersection of the vertical and the vertical line trim condition. Now prismatic coefficient nothing but the and the underwater volume divided by the same length on the ship's waterline and the area at the midship. Okay, so presently is the ratio of volume of displacement of the ship. Volume of the ship to the volume of the prism has the same length as the ship's waterline, the same crossing as the ship's intersection, and extend the bottom of the and extend from the ship's waterline on the waterline to the graph perpendicular is basically the distance measured along the basically it's a vertical line at the aft touching the somewhat low line and the rudder stroke of the vessel. A line run perpendicular to the load line through the aft forced through the axis of rudder stroke as the stamp of and the somewhat load line ship stamp and the somewhat load line load displacement somewhat load line load. Okay, stable equilibrium as when cool GM is positive and GM must be negative. Neutral in for unstable it should be Km must be lesser and Gm and Kg is more. So in that Kg must be greater than, so it's for neutral equilibrium. Okay. So the point at which this happen that Kg and Km becomes 0, the point comes as the angle of flow. Km increases as angle of heel increases. Again, it reaches a maximum value at some angle of heel at an unstable over which more and more it may happen, so angle of heel is sufficiently to equal Km increase sufficiently to equal to the Kg. The vessel then until it reaches a maximum value and some as an unstable vessel over more and more it may happen that process of neutral equilibrium and the angle at which this happen is called the angle of flow. And happen at angle another one when unstable vessel in this flow falls into the angle of field to my awareness. Corrective action. Now we have to reduce the FSC. We have to see for any vessel which is at the center line of the vessel, and if it has FSC we have to fill it up, and apart from that we have to look for any FSC tank, then we have to fill it and then press up press up all slack tanks around seawater in a DB tank which is at the smallest point of inertia with center line and is not on the center line of the vessel, then on the lower side of first, and then after it full its counterpart on the higher rapid inches and so on. I don't know. Press up all slack tank is the first point. Press up all tanks. Okay. Run up the seawater into DB tank which has the smallest moment of inertia about the center. Okay. Justification, we have to lower the center of gravity so the GM become positive at an angle of lol. Any existing FSC must be eliminated and minimized required to be internal so that the tanks finally remain slack at those smallest one area about the tank center line. While running up the intros, FSC will be created. This must be kept to a minimum while running to fill up the tank with the smallest amount of inertia as so triangular TPC this one. Okay, no damage stability booklet, damage cases description, damage compartment capacity, compartment openings, damage table and damage calculation, damage and and extent of damage is representative of damage compartment coupling non-damage representative of damage stability calculation representative of damage stability calculation principal per extent of damage and damage criteria description damage capacity okay representative of damage stability calculation representative damage stability calculation capacity of damage opening information damage cases description representative of damage. What is stream and stability booklet? So as commercial ships usually have a stream and stability booklet which may contain either curves or form hydrostatic tables and book stability and trim characteristics for various conditions of loading. A typical trim and stability the following table following data the vessel characteristics including principal dimension tonnage locations builder and officials. Okay, so the hydrostatic trim booklet consists of the nomogam curves used for the hydrostatic tables from where we can get the km and kg LCO hydrostatic data and gz curves and gz curve kn cross curves and ship particulars and plimsoll marks dimensions and basically capacity of the vessels and km. Okay, that's it. And yeah, that's it. 3 things I got remembered. About it has total 7 things. So first again, which I say is hydrostatic data, that is km, lcf, and capacity of the compartments and their locations, not location, sorry. Second thing is about the plimsoll mark and their details and dimensions. Third thing, principal particulars of the vessels. Then nomogam curves for the hydrostatic table and how to use it. Then we can have basically GZ curves, cross curves prepared by the dry dock, and we can have that and how to use that cross curves and all. We can know about it, and what we can have is I don't know. Let's see what I'm missing. So first, vessel characteristic include principal dimension, tonnage, location of draft marks, builder, official registry number, etc. So in that I have only remembered the plimsoll mark. It is not there only, so I don't have to use word plimsoll marks. I have to use tonnage, location of draft marks, tonnage, location of draft marks, principal dimension, official and registry numbers, etc. Builder, official number, exists. Okay, draft marks. Okay, principal dimension and tonnage and draft marks, the locations and builders official. Okay, now instruction for the use of nomogam curves and other data in the builder to calculate stability and trim of the vessel for given loading condition. General operating instruction precaution. Okay, tabulated tank and hold capacity. Okay, general operating instructions and precautions. Then general operating instructions, precautions, hydrostatic properties, km, lcv, lcf, etc. Okay, now metacentric GM diagram showing GM for tabulated condition of loading and for vessel service. Okay, GM diagram showing GM for tabulated condition of loading and minimum required GM. Okay, minimum required GM for vessel service. So That is vessel principal dimension, tonnage, location, transfer marks, and then metacentric GM. Metacentric GM diagram showing GM for tabulated condition of loading and minimum required GM for vessel service. For vessel service, metacentric height GM diagram showing GM for tabulated conditions of loading and minimum required GM for vessel service, 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 required GM, and metacentric GM showing GM or tabulated condition of GM for vessel service. Okay. Trim diagram to calculate the vessel trim with trim diagram to calculate vessel trim when weight are added at location other than the vessel center of gravity. Trim diagram. Okay. This I have missed. Trim diagram to calculate vessel trim when weights are added at location other than the vessel. Now weight distribution stability information for various condition of loading liquid cross curves कहीं पे भी यूज़ नहीं हुआ है. Okay. GM बता initial metacentric GM diagram, then trim diagram for tabulated condition of loading and minimum required. Now trim diagram to calculate vessel trim when weights are added at location other than the center. Okay. Now weight distribution stability information for various condition of loading and liquid loading diagram showing the location, capacity and effector and list and trim of the vessel. And trim of the vessel tank. Okay. What is FSC? FSC is nothing but a slack tank in which the liquid shifts to one side causing an virtual loss of GM, and it can be measured by the inertia of that compartment and the density divided by the GM fluid into weight, and where else it can be as FSC. So this is basically inertia into density divided by weight into the shift into the weight. So is inertia density by or not shifted with inertia into di density divided by weight fluid GM. So F is calculated by FSC equals to inertia into moment of inertia, density of the liquid slack tank, displacement of the ship in tons. Okay. And GM solid is basically GM fluid. Can be calculated quite easily and is called free surface correction, FSC. Effect over the liquid on lower side and thereby causing the angle of roll and period to increase. The vessel as the GM has been reduced. So this is all about GZ curve is basically for assumed value of kg we are getting GZ and displacement on the y on the x-axis, and on for different GZ curves are a set of where GZ is computed for an assumed value of kg. For any angle then we can calculate the GZ is computed for an assumed value of kg. GZ is now how cos of positive stability we come to know. Now this is GZ curve. KN curve is where the center of gravity is considered at the keel of the vessel. So KN curve is a set of curves when kg is 0. KN curves, KN is a writing lever measured from the keel. I will separate on y-axis. KN is given meters. The shipyard. I know this. So after loading, so the kn curve is basically this can be as in the assumed value of kg is quoted for assumed value of field and angle of field and is displacement. We can calculate value of gz. For any angle of heel and displacement, we can angle of displacement we can use. So after completing the operations, basically, time playing.